And this one we are Google meeting. There's nothing happening here. No, it's just, oh, I'm on, but there's no, oh. It's okay, it's just me, so no one else is watching us. Guys, these are all different. That one's different to this one. Priyasha! Hello, Priyasha!
Welcome to the dog
Sound.
Wow.
Welcome to the...
Priyasha?
Should be working.
Priyasha?
Hi, ma'am.
Can you see?
Hi.
Can you see?
Yes.
I must get another bucket. So we're using Hannah's iPad as the Google Meet one, and we're using my husband's one as the taping one. Okay, I'm just using him now. It's actually a good idea. All right, guys. Okay, so for today, because I get the feeling that you guys are still a little bit worried about what we've been doing while on. Am I right? Okay, so all right, let me just go into Google Classroom and find. Let's finish that worksheet. And then we'll go, you also want me to go over the number one. I know some of you did very well, but I know a lot of people battled in number one, even though it was a past paper from last year that you wrote. Okay, so, all right, so we'll go over here. Okay, so maybe this is going to work. So maybe she's not going to have her iPad anymore. I'm just going to keep it. Okay.
How to protest.
You see my old one, the one from school, it doesn't even allow me to use Google Meet.
That's so weird.
And my laptop, the camera isn't good enough. And I don't know what else. My phone, she couldn't see yesterday, so yeah. All right, let's do this. But now, where are these other people in your class? That's what's worrying me. Okay, guys, so we were busy talking about, we got up until the variables, I think. Yes, we got up until question number 3. Okay, so we had, I'm trying to check where am I now. Okay. Tell me if you can see Priyasha. Priyasha,
Yes, I can.
can you see?
Yes.
Yay. Okay, I'm happy. All right, so we had 4 test tubes, and in those test tubes there were different concentrations of sugar solution, like if you mixed Oros very strong to weak, and we said the potato cylinders were all the initial same length, and they were left in their solution. Come, you to remind me.
24 hours.
24 hours, and what were the other
Same
control
volume.
variables? The same volume of solution in each test tube.
They're the same length and the same mass.
Yeah, although it was a bit of a weird question now when I started marking. They're all the same length, and then they measured the mass of them at the end, which will work, but they didn't measure the mass of them at the beginning. But it still works because they're all the same length at the beginning. So when you do controlled variables, always say same this and how. So if they tell you they were all 5 centimeters long, cut with a ruler, say it, although it didn't say here. If they tell you the same volume of solution was put into each test tube, how? 10 mils using a syringe. You see, that's what we start doing up until matric, and even your pracs later on in the year when you get this, okay? They were all placed in the same solution for 24 hours. How? Time, okay, maybe you won't time with a stopwatch for 24 hours, but if it was, say, 10 minutes,
Using
time
a
with a
clock.
stopwatch. Yeah, you can use a clock. So we've noticed now that the IB, because we train you for them, okay, for matric, so they're giving now 2 marks or sometimes 3 marks per controlled variable. So time is controlled, they used to do 2. Time is controlled, 24 hours how, or maybe 10 minutes, time with a stopwatch. So they would actually give you 3 marks. So they, different examiners, they change it as we go along, and we see that when we go and mark, or when we have to mark, okay. All right, so the next question was, oh yeah, I need to put this on. This is multitasking and I can't even cope.
Ma'am,
Yes.
how far away do I have to sit to take my mask off so I can put my glasses on?
I don't know. Can I ask? I don't know. Can I ask what they say? They haven't. I don't know if you can take them off in class.
30 meters or something.
Just put it down below your nose.
Yeah, you can put your no.
Yeah.
And then if it fogs up, just hold it here. That's what I do. And then it doesn't fog up.
Oh, those are school ones. He's like,
Or just put your glasses on top of the nose.
Really? Does that work?
Yeah.
okay. have here now? So question number 3, I don't have the model here, okay? It's okay, because I remember all. So, we've done number 3, then number 4, which potato cylinder, A to D had been, I didn't press record. Oh no, I did. I'll get into this. Okay, I'm recording. All right. 4. Which potato cylinder A to D had been immersed in a sugar solution of the lowest concentration? Lowest concentration, which means less sugar, it's very dilute, there's more water. If there is more water, if it's a very dilute solution, there's very little sugar in the water. So in terms of osmosis, if it's more dilute, and it's more dilute compared to these solutions, which one is it?
D.
D, because? Hang on. If it's very dilute, it's, yeah.
Oh, sorry.
Hang on, say it again.
Yeah, A. Because the mass increases, which means there's more sugar.
Okay, so if it's a very dilute solution, so more water will move into the potato cylinder which is placed in that sugar solution, because there's the highest concentration difference, or the highest concentration gradient. No, guys, this isn't working. Okay, hang on. I told you my mind is down there. All right, placed in the most. Oh, you know why? Because I've colored this in,
Yeah.
and it's confusing me. I just did that yesterday as an explanation, and I did it again today, not realizing that it was just an explanation. All right. So which one was placed in the most dilute solution? It would be the one that increased in mass the most. Okay, yes. Because more water is going to move in by osmosis. Does water move out?
Yes.
Yeah. But there's the biggest net movement of water into the potato. What was it called? Potato?
Cylinder.
Not a potato, not something else, okay? Because you can try and squeeze a whole potato in that test tube. All right. So the answer is A, because the lowest water concentration is in the solution. All right. See, I don't need this. Those dots were confusing me. Okay. The lowest water concentration is in the sugar solution, so therefore more water moved in, and therefore there was the greatest increase in mass of the potato cylinder. 3 marks. Okay, you could even say there was the higher concentration gradient, high to low. More water moved in, and you need the biggest increase in mass. You can't just say, what did some people say? They said the mass increased. So did these two. There was the biggest increase in mass, more water moved in. What was the other one? And more water moved in, increase in mass. Yeah. Okay. Are we happy? All right. More water in, increase in mass. What was the other one? Osmosis, high to low, something like that. Okay. Right, number 5. Which potato cylinder had been immersed in a sugar solution nearest in concentration to that of the potato cells? The one in test tube? C. Because if we look at the graph, what does it tell us?
There's barely a change in that.
Yes. There was hardly a change in mass. So C, yes, more water did move in, but quite a lot moved out as well. So there was a slight increase in mass. So that's your first part of the answer, because the mass only increased a little bit. So therefore, the concentration of the solution in the vacuoles must be quite similar to the concentration of the sugar solution in the test tube. So there was a slight net movement of water into the cylinders. Okay. So you always start off with Y, the increase or decrease in mass, and then refer to osmosis. Because I know, last year I taught most of you last year. So I always used to say, when you talk about diffusion or when you talk about osmosis, you talk about 4 things. What's moving? What's moving here? Water.
Water.
Okay. Where's it moving from?
The Test tube.
The solution in the test tube. There is a lower water concentration in the solution in the test tube. So what's moving from where? From the test tube, the solution in the test tube, sugar solution in the test tube, into the cells where there is a higher concentration of sugar. So there's a slight net movement of water in. So what's moving? Where's the high? Where's the low? Okay. I said 4 things. That's because we used to say, okay, for diffusion we said, what's moving? Where's the high? Where's the low? For osmosis we say, what's moving? Where's the high? Through what is it moving? I didn't give a mark for that though. The cell membranes, I didn't give a mark for that because I didn't ask you for a definition of osmosis to where's the lowest water concentration. So more water is moving from a region of high water concentration in the solution in the test tube into the potato cylinder where there's a slightly lower water concentration because it's a sugar solution. And how do we know that this was near to the concentration of the potato cells? Because the mass didn't change so much. Okay. You know what? That's why I asked you guys to do these worksheets. And I even, when people are at school, we do them in class, and I let them mark them, and then I take them to moderate them at home. And they all give themselves, 13, 14, 15 out of 15. And then I go and give them 8, 9, 10. Not because I'm mean, it's because I'm reading what you say. And it's hard to explain osmosis. It's hard to do that. Okay, what was that? Who else has joined? Anyone? No? Okay, I don't know. Okay. All right, so you've got to get the wording right, and that's why I've printed them out, and then I marked them and scanned them off so that you could see how I was trying to make. Some of your answers are like, guys, I don't want to mark essays for 3 marks. It's hard for you to do that. You need to scale it down. So so first of all, how has the mass changed? How do you know that? Look at the graph. There was not much change in mass. There was a net movement, there was a slight net movement of water into the potato cylinder because the solution on the outside has got a similar concentration, or the water concentration is slightly higher outside than inside. Okay, then I can see, oh, you understood it. All right. Okay, next one. What's the other one? Yes. Predict what will happen to the mass of the potato cylinder if it is immersed in a sugar solution equal in concentration to the cell sap of the cells. What will I have on the graph?
No change in mass.
No, so you won't even have a little bar here. So if it was in the same concentration, you just draw like a little line. And we've had graphs like that before, where we've had to add, I'm thinking matric or grade 11. So you just put a line saying, yes, I know it's there, but there's no change in mass. So in other words, if that is the test tube, and there's the potato cylinder, does water move in to the cylinder?
Yes.
Does water move out?
Yes.
But exactly the same amount. So will there be a change in mass?
No.
No. So what will our answer be? What was the question again? The wording. Okay. I know it's only about mirrors. I just want to get the exact wording. Predict what will happen to the mass of the potato cylinder if it is immersed in a sugar solution equal in concentration to the cell sap of the cells. Well, the mass of the cylinder would
Stay the same.
stay the same because
There's no net movement
of water, because the concentrations of sugar solution outside in the test tube and in the potato cells is the
same.
But that's actually part of the question. How much was that question out of?
3.
Okay, so there's no net movement of water. There's no change in mass. What else did I give? See, I need my model. What else did I give a mark for there?
I got a mark for saying equilibrium.
Yeah, something like that, yeah. Okay, as long as I can see that you've understood. Because some people say water doesn't move. Well, that membrane is porous. They're still moving around, all right? But there's no net movement of water. The same amount in and out, therefore no increase in mass. Okay, so if I give you a prac on osmosis later on in the year, you're going to be good.
Yes.
It's not that hard. Okay, that's why I do it in grade 9, because it's a I think it's an easy concept, but I know it's hard to word it. All right. Okay. I know it's hard for people to word. All right, Priyasha, you okay?
Yes,
You
ma'am.
can leave your mic on. Okay.
Now,
So-
can I quickly ask a question?
Mm.
You know, I know it's the previous, it was a previous test, but it said 25% sucrose solution, 50%.
Should we go? We're going to go look at that
Oh,
right now.
okay, cool. Thank you.
Alright. Okay, so now I'm just going to find it. Because this is in the cloud. And I just, like, which lesson did I put it in? So it would have been plants and animal cells. Was it number 11? No, that was the starch bag one. Osmosis. See, this is where I actually need the names of them. I can go look in my drive. No, it's not going to be here. Okay, let me just see if I can find it again. I've got time. Track, do, that's model, okay. Catch up lesson. Yeah, I'll give you lots of catch up lessons. Try point, let's see what this one is. Otherwise, I'll put it on Google Drive. Another catch up lesson. Jeez, that. God, I hope it. Okay. Now, let me just get into my drive. Okay, schoolwork. 13. Sorry. Plant and animal cells. Okay, I think I've got an older version here because then I changed it into one for Google Drive. Let's just use this one anyway. Okay. I don't want to
Yes,
pull
this
the one
one.
up. The one on Google Drive has just got, yeah, it's fine. Just tell me if I've changed the questions a little bit. Okay, so what do we have here? This was the one you had in July last year. So how many of you realize that? That's okay.
I just knew because it said 25% and the last one also
No,
had
it's
that
fine.
percentage thing.
You know, there were people who weren't here last year, so it's fine. I don't mind. Okay. All right. Priyasha, can you see?
Yes, ma'am.
Oh, I'm so happy. Okay. The diagram below shows an investigation that was set up by a pupil to demonstrate the process of osmosis to her fellow classmates. She filled, so this time not test tubes, she's got 3 dialysis tubing bags. Okay, so let's see, what do we have here? Red pen. All right. 3 dialysis tubing bags with different concentrations of sugar solutions again, and she placed them in a bowl with 1% sugar solution, and she left them for 24 hours. So, 3 small dialysis tubing bags. What variable would, well, they didn't tell us everything, but what variable could that be? The controlled, okay, because they're all going to be the same size, different concentrations of sugar solutions,
Independent.
so independent, and place them in a bowl which contained a dilute solution. They're all in it.
So control.
Yeah, could be that. Okay, and left the bags in the solution for 24 hours.
Control.
Controlled. Okay. So, I'm just going to move it up. So, what does a 25% sugar solution mean? So, here we've got a 1, so wait a minute. So, bag A has got a 1% sugar solution, bag B has got a 25, and bag C has got a 50, and on the outside is a 1% sugar solution. Okay, let's put it in. Okay. Right. So what does and I mean I didn't expect you to give the big scientific definition here, but what does that mean? If it's a 25% sugar solution, it means 25% of the solution is
Sucrose.
sucrose, and the rest is?
Water.
That's it, nothing else.
Oh, so we're still 10 milli. That's what I was confused about.
Oh, down below, I think it says that 10 mils was placed in each bag. So
Yeah.
that would be a Controlled variable
But-
volume.
But then how would you get, so is 25% of that 10 milliliters sucrose?
Exactly. So that's 10 moles. 25% of that is sugar, the rest is water.
Okay.
If this is 10 moles for the 1%, okay, 25% sugar solution, 1% is sugar, the rest is water.
That makes so much more sense. Okay, thank you, Mel.
Okay, so it's like a question. I think maybe that's why people battled.
Yeah.
But I thought you would know that. Okay, it doesn't matter. All right, then 50% obviously you would have lots, half of it would be sugar, very sweet. Okay. Like some of you make your tea, huh? All right. Which bag would have increased in size the most? Just tell me the question, brothers and sisters. Explain by referring, why? By referring to the process of osmosis. So which bag would have increased in size the most? It would increase in size the most when it's in a, what type of solution?
Dilute.
A very dilute to compare to what's inside it. Okay, we're just going to finish. So which one would have increased in size the most?
50%.
Yes, okay. So will water move into the bag?
Yes.
Will water move out?
Yes.
Teeny bit. There's a greater net movement of water into the bag because the concentration gradient is very high. You know what I mean by concentration gradient is high? I always say water moves from a region of high concentration to low. Not really high to low, but there's a big difference in concentration. The more water moves in, there's the biggest net movement of water into the bag, and therefore it increases in size the most. See, it's a story, okay? All right. And you could talk about the highest water concentration is in the 1% solution in the bowl, and the lowest water concentration is the 50% sucrose solution in the bag. See there? Okay. Right, next one. And then we'll switch off and then we'll do another video just now. You see, I've changed questions. What's your next question? Oh wait, I've got something.
I think you have one.
Hey? No, what I mean is when I put on Google Classroom, I made it different. So I'm going to look at someone else's here.
Because I don't have that worksheet.
But I gave it to you yesterday, didn't